Welcome, recruits. I am absolutely thrilled to have you here for today's briefing. You know, when I first dropped back into Earth's gravity after a long mission, I realized almost immediately that the hardest part was actually just beginning. I mean, imagine spending months floating in space, looking down at Earth from hundreds of kilometers above, just living in this incredible environment where gravity simply doesn't exist. And then, the journey's over. You're home. But from an astronaut's personal viewpoint, the mission definitely does not end when that spacecraft lands. In fact, a brand new, intensely physical challenge kicks off the literal second you touch down. So this explainer is going to show you exactly what to expect.
Here is your mission orientation docket for today. First, welcome to Earth gravity. Then, musculoskeletal atrophy and recovery, followed by cardiovascular and vision shifts. After that, we'll cover psychological re-entry and adjustment, and we'll wrap up with future hazards, the Mars horizon. This itinerary is going to prep you for the physical and mental hurdles of returning home.
All right, Section 1. Welcome to Earth gravity and the crushing weight of 1G. For millions of years, our bodies evolved under Earth's gravity, right? It dictates our muscle development, our bone strength, even our balance. Without it, you change entirely. Up in space, you're completely weightless. Sure, your inner ear receives some totally confusing signals at first, but you adapt. Then you land. And it is a completely jarring contrast. It literally feels like someone just strapped a massive, incredibly heavy backpack onto you. You're going to experience extreme dizziness, nausea, a total loss of balance, and some really severe motion sickness. Honestly, many of us returning crew members need immediate physical help just to stand up out of the seat.
After months of just effortlessly floating around, your brain suddenly has to completely relearn how to interpret the signals from your eyes, your muscles, and your inner ear balance organs. It makes even the most basic, simple tasks feel monumental. You're quite literally going to experience the sensation of learning to walk all over again. Even lifting a standard cup of water is going to feel surprisingly heavy to your unadapted muscles.
Moving on to Section 2. Musculoskeletal atrophy and recovery, or rebuilding the foundation. Let's look at exactly how your body degrades when you don't have to carry your own weight, and the medical protocols we use to get you back into fighting shape.
The harsh reality of microgravity is that even if you are diligently doing your 2 hours of daily exercise aboard the spacecraft, you can still lose up to 20% of your muscle mass on these long-duration missions. Because you aren't supporting your own body weight up there, your leg muscles shrink, your back weakens, and your core loses a lot of its structural strength. So, to rebuild those muscle fibers, you're going to follow these strict daily rehabilitation steps the minute you land. And guys, this protocol is intense and completely non-negotiable. Strength training starts immediately. You'll have daily, scheduled physical therapy sessions, kicking off with gradual walking exercises and eventually scaling up to heavy resistance training. But hey, the good news is that with this dedicated routine, most of us recover our normal muscle strength in just a matter of weeks or months.
Now, looking at the technical focus of our space medicine, we have to closely track how rapidly your bones lose calcium. Because bones constantly rebuild themselves based on the weight they actually carry, living in microgravity causes bone loss to happen way faster than bone formation. We're talking a 1 to 2% loss of your bone mass every single month. Basically, a 6-month mission can trigger changes that look just like decades of aging and osteoporosis down on Earth. This is actually a massive area of study, because observing how our bones degrade in space is helping scientists treat aging patients right back here on Earth.
From a mission planning view, we really have to contrast that quick recovery of our muscles with the totally grueling battle for bone density. Unlike muscles, bones recover incredibly slowly. Your rehab protocol is going to require several years of specialized diets, intense vitamin D supplementation, and continuous weight-bearing exercise. And just a heads up, after really long missions, some of that bone loss might never fully reverse.
All right, Section 3, cardiovascular and vision shifts. Fluid dynamics in 0G. We need to talk about what happens to your internal fluids when gravity stops pulling them down to your feet.
Up in orbit, your blood shifts upward towards your head. That's what gives astronauts those puffy faces and thinner legs, while actually reducing our overall blood volume. But when gravity suddenly yanks all that fluid back downward on Earth, your heart has to rapidly readapt to pumping efficiently again. If it doesn't, you're looking at severe low blood pressure, extreme dizziness, and a massive risk of fainting. Your recovery protocol here relies heavily on intense hydration, constant medical monitoring, and cardio training. Thankfully, cardiovascular functions usually normalize within a few weeks.
But that fluid shift causes one of our most concerning medical discoveries, SANS, or spaceflight-associated neuroocular syndrome. Because all that fluid shifts towards your head, it drastically increases the pressure around your eyes. Astronauts routinely deal with blurred vision, difficulty focusing, and literally structural changes to the shape of their eyes. Brain scans have even shown structural changes in the brain itself after long missions. Scientists are still utilizing continuous monitoring to study the long-term effects of this.
Which brings us to Section 4, Psychological Reentry and Adjustment. Surviving reentry isn't just about repairing your physical body. Coming back to the sheer noise of Earth is a massive psychological shock.
Think about it. You've spent months in this highly controlled, incredibly silent, isolated bubble. When you come back down, you get hit with immense reverse culture shock. The sensory overload from crowded cities, roaring traffic, everyday noises, and the sudden weight of social obligations, it can be totally overwhelming. Transitioning from the quiet, structured routine of space back to the chaotic pace of Earth is an emotional adjustment that is just as real as the physical one. But there is a pretty incredible silver lining to all this emotional upheaval. Witnessing our planet from the void triggers something called the overview effect. Seeing Earth from space just fundamentally changes your outlook on planetary life. You come back with this profound appreciation for our world and a vastly stronger commitment to environmental protection and international cooperation. It really changes who you are at your core.
Finally, Section 5, Future Hazards, the Mars Horizon. Everything we've discussed so far, the bone loss, the fluid shifts, the sensory overload, it is all merely training for the ultimate test, the journey to Mars.
Here is the math you really need to understand. Mars only has 38% of Earth's gravity. A mission there takes 6 to 9 months just to arrive, several months on the surface, and then another 6 to 9 months back. That's a 2 to 3 year mission duration. And the truth is, we still don't fully know how years spent in that severely reduced gravity will affect the human body long term. Plus, once you leave Earth's protective magnetic field, radiation becomes public enemy number one. You're facing relentless cosmic rays that massively increase the risks of cancer and nerve damage. We are constantly emphasizing strict safety protocols because the logistical hazards out there are terrifying. You'll deal with extreme isolation, communication delays of up to 20 minutes each way, and absolutely zero emergency medical support or evacuations from Earth. You are entirely on your own. So remember this quote, because it really hits the nail on the head. Surviving Mars isn't just an engineering problem. It demands extreme biological resilience. Every astronaut who returns to Earth provides crucial data. Our recovery teaches us how bodies adapt and how we can prepare humanity for permanent settlements out there in the stars. Seeing the grueling physical and psychological recovery required from just a standard 6-month orbit, it leaves us with one vital, lingering question. Knowing the toll it takes, the rapid aging of our bones, the radiation, are we truly ready for a 3-year journey to Mars?